Okay, this is video number 4 for the lab experiment number 11 of EEE202. The previous 3 videos were done in the lab, and now I'm taking some time to go over what you should be doing in LT-SPICE. The lab write-up, or the lab manual, has instructions in it for PSpice, which can be confusing when you're trying to convert that over to this LT-SPICE. So that's why I'm preparing this video. Based off of the work that we have done previously, I would anticipate everyone could get to this point here and generate this circuit using the resistor component, capacitor component, and drawing the individual lines, and then using a voltage component here. So going to voltage and then selecting that voltage source and putting it over to the side. Okay. And then of course putting a ground point on it. I believe I've also put these labels here. I believe I used this, label net, to put in V1 and V2. Not essential, but can be helpful. Okay, and then this is our measured resistance from the experiment of 4710 ohms, 4.71 kilo ohms. And then here is we didn't really get a chance to measure it, but we are going ahead and making the assumption that what it said on the box is correct, and this would be 100 nanofarads for the capacitor. So again, I expect you can do all of this, and then the thing I wanted to show you is that with the voltage source, in order to get a square wave, which is what we want for lab experiment number 11, you'll go ahead and right-click, and when you bring this up, you'll go to advanced, okay? Because this isn't going to be a simple DC value. So when you go to advanced, it brings up this screen, and the pulse is what we're interested in here. So you'll select pulse. It'll give you these boxes to complete. And so what we're wanting to do is we're wanting to do a 6-volt peak-to-peak square wave. And it's going to go from minus 3 volts to 3 volts. So if you'll simply put in minus 3 on V initial, 3 on V on, and then for the time delay, that has to do with the time period before it starts doing the cycle. And you can put whatever you want. I went ahead for mine and put in 3 milliseconds. And you can do 3 milliseconds by putting an M, lowercase m, next to the 3. The rise time and the fall time, we want it to happen as a square wave, so we want it instantaneous, but for reality's sake, let's go ahead and give it a duration, and we'll make it very small. So the rise time is 1 picosecond, and the fall time is also 1 picosecond. Okay, and it is the period total is going to be 6 milliseconds. And we want it to be a symmetric duty cycle. And so it's going to be on for half of that, 3 milliseconds. So it'll toggle between -3 and 3 volts with 3 milliseconds on for both. For end cycles, we're not going to put anything. We'll go ahead and leave that blank. You can go ahead and experiment with that if you'd like to see what that does for you. But for this, we'll go ahead and just leave those values. It has make this information visible on the schematic. I like to have that checked, so we're going to go ahead and leave that. So we'll just go ahead and hit OK at that point. And there's that display that I was talking about. So that gives all of those values that we just entered in if we wanted to refer back to it from the schematic. When we're at this point, then we can go ahead and hit our run symbol up here in the menu bar. And when you click on run, it will give you this screen. And we've been using this DC op over here In this case, we're actually going to do the transient. So that's the first tab. So we're in the right tab already. And we're going to have a stop time. What I chose was 0.02 seconds for my stop time, and that we would start saving data right away. So just go ahead and put in 0. And then there would be a maximum step time. So we would have steps of, I went ahead and selected 1 millisecond. I think I could have put 1M in there and it would have been fine, but I went ahead and put all the zeros in. Yeah. Okay. And then we don't need to select any of these here. Again, if you want to experiment with that, that's fine. And then we'll go ahead and hit OK. All right. And so now we have a plot. We have a screen to work from to show the various voltage values that we're interested in. And we're certainly interested in the pulse. So let's see how well we did with our square wave. So when you get over here to this point right here, anywhere along this line is going to be the same voltage, right? So you can click anywhere in there with this red probe tip, and it will give you the V1 trace, so this voltage value. Okay, so it looks like we got what we identified as a delay of 3 milliseconds. And then we go on. We're starting out at minus 3 volts, go up to plus 3 volts. Looks very good. And then we have a drop after it's been on for 3 milliseconds, and it's off for 3 milliseconds, and back and forth. So it's doing exactly what we want it to do. So that's great. Okay, and then you can come over here, do the same thing to see what the voltage across the capacitor is. Now there's two ways you can do this. Since in both instances here, they're tied to ground on the other side, you can just click at this point and it'll give you the voltage across that capacitor. Okay, if you're interested in this resistor, what you can do is you can click on one side with the red probe tip, keep the left button clicked down, don't release it, and go over to the other side with a black probe tip. And when you release that, it will give you that voltage across the resistor. Okay, so I'm not going to do that for you here. I want you to kind of explore with that. That's part of the post-lab evaluation. But we'll go ahead and show both of these so I can show you a couple of other things. So up here we've got our legend in green. That's the V1 voltage across our power source. So that makes perfect sense. And then this should look really familiar if you've watched the video. This should be very familiar to what we're seeing, which is the decay, exponential decay, and then the exponential rise back and forth across the capacitor due to the transients. So if we want to get rid of the trace, we can go up here, right click on it, and then we have the option to delete it. Okay, and then just bring it back like that. If we want to display cursors on the screen, which I think you will because you're being asked to find out what the time constant is, and so cursors can be very helpful with that. So when you come up here, if you left click on the one that you want to put the cursors on, so in this case it's going to be the blue line, the capacitor line, it brings up this box over here. If you click on it a second time, so again left click, it opens up a second cursor. So you can actually get two cursors on the screen at the same time. And it'll calculate a difference for you as well. So when you bring it up here on the screen, you see it turn into a 1. So when it's a 1, if you click down with the left mouse button and move it, then wherever you drop it, that is going to be the what it's going to measure for that cursor. Okay, so I dropped it right here, and at that point, it's at almost 12 milliseconds, 11.98 milliseconds. And the voltage level at that point is 2.989 volts, which looks about right. Okay, so then we could take this cursor and we could drag it over here. And if you'll recall, we were looking for where it dropped down to, I believe it was like 3.78 below that. So you can just kind of move this along until you get approximately where that's at. And then it's going to give you, and I didn't do that, but I'm just putting it there for instance. then it gives you what the coordinates are for both of them. And so now you have a coordinate for the you have a coordinate for what the voltage is and a coordinate for the time. And of course, it's the time that you're going to want to use to do your time constant value. Okay, so I think that's really all that I needed to show you for this particular lab. This is very useful. If you want, you can go ahead and do some of the experiment by changing these values and just seeing how it changes things in the plot. It's very nice, handy package to be able to simulate all this using LT-Spice. And we'll go ahead and close this video segment here. And good luck finishing up experiment number 11.